You listening to Trigger Seattle podcast.
Has been a lot of talk about spectrum frequencies, spectrum interferences, and many companies try to merge with another companies just to get their hands on a spectrum. I even heard about spectrum auctions can bail out nations out of debt. And companies like T-Mobile, Verizon, AT&T, they cannot use the same spectrum in the same market at the same time. Vadim, as you're working in telecommunication, can I pick up your brain about spectrum? What is spectrum really is?
It's the livelihood of any wireless communication.
Interesting.
Without the spectrum, without the airwaves, we cannot communicate. The airwaves carry the signal, whether it's a conversation, whether it's your internet session, whether it's you piloting a drone or something. So that's the livelihood for any wireless provider, operator, or entity.
The cellular phone spectrum is different from radio spectrum, and why is that?
They're all part of the same electromagnetic spectrum that starts from 0 frequency, 0 hertz frequency, going up to megahertz, gigahertz, and terahertz, right? And it ranges between the lowest parts of that electromagnetic spectrum is our wireless RF propagation waves that we use for radio, TV stations, and wireless communications as telecommunications providers use. Then we go up in the range, and that's our color spectrum. When it's infrared, which is we don't see, then the colors that we are able to see, that back to your physics lessons. And then up to ultraviolet, which we also don't see, but we feel it when we're on the sunshine. We feel the burn when our skin gets burned, right? And then it goes up, and with a higher frequency, the more negative health effects it might have
so
for us.
Spectrum can be dangerous for health.
The spectrum itself, like electromagnetic wave, yes, because it's the wave of electrons that penetrate everything, basically.
Okay.
We don't see it. Basically, it's subjected to the electromagnetic wave, which is high frequency, and the electrons, and they penetrate our body, and they can show our, bone structure and everything. And then we go up, and we go to gamma wave radio, gamma radiation, which is dangerous to our health because it's part of that nuclear reaction or atomic bomb explosion. Yeah, so the frequencies are livelihood. The more frequency the operator has, the better they are, no matter what.
Interesting.
There is not a single megahertz, like somebody said in the telecom industry, there is not a single megahertz of spectrum I don't like. One of the executives said, I don't remember who was it.
For how long we use the same spectrum in 5G and before?
That's a great question, because most of the spectrum we use for 5G is the same spectrum that we were using for 3G and 4G, for example, like LTE and UMTS standards. The only new addition to the spectrum range for 5G, and that's what probably caused all this conversation about health effects, is a millimeter wave range. We didn't have that for LTE, we didn't have it for 3G or UMTS. We started using it for 5G. That's higher frequencies, yes, but at the same time, the telecom industry is fairly regulated, fairly heavily regulated industry, and everything is being regulated, not only spectrum, but also the power of the devices that you use. The more power you have, the more effects, the more electrons you're being subjected when it's, we're talking about electromagnetic radiation.
Yes.
This is all electromagnetic radiation, electromagnetic waves.
Yes,
right?
that's interesting.
So, yeah, and with the phones, we basically have very regulated power levels, and we're not increasing power levels, as far as I know, to the dangerous, highly dangerous ranges, right? It's definitely the power of the phone. It's definitely less than the X-ray power.
Very interesting. Apparently have a lot of value in it if we have so much demand and company try to get for specific spectrum. What will be the difference in technology between 5G, 4G, 3G, and so on?
So let me give you a little example, just a quick bite on all that G stuff. The G means generation. And I think the G stuff, the number and the G, it doesn't mean anything. It's just like 4G, fourth generation, 5G, fifth generation is going to be 6G, 7G, and so on and so forth, right? When the first phones I think it was in Europe as well, they came out, the first mobile phones, it's considered to be a 1G. The other stuff, how we can look at it, it's a wireless standard standpoint or the capabilities that the networks brought. So that's the the 5G stuff. That's what that means, the capabilities of the network. 1G, very easy to remember. First network, just mobile phone. You can make a call without being connected to the wire, right?
No maps,
nothing,
no search engine, no
huge
video
phone
camera.
you were carrying, right? So 2G,
Okay.
GSM, usually like that's where GSM was born, right? And that stuff allowed you to send texts, first texts, right? That's some. So you can make a call, you can send a text. So that's a 2 generation, plus you can use different frequencies. They use like 900 megahertz and 1.8 gigahertz and so on and so forth. 3G, that's another evolution or a revolution standard. It allowed data on the phone, but you can only either talk or use data. It was just like you can't use both until some point. 4G came out. That's where they started to talk about G stuff.
Okay.
Before that, they probably mentioned 3G somewhere, but the general population, they were not talking about it, I think, in my opinion. I might be wrong. But 4G was LTE, actually. LTE, somebody heard about LTE, I think. And that's the name of the standard. That's actually the name of the standard. But it was considered to be 4G. That allowed us to use our phone, data, video, some applications, and then the 5G came about. The actual name of it is NR. It's called NR, new release.
New release.
That's it.
Interesting.
LTE stands for long-term evolution. So
Interesting. Very
interesting names, right? But
Yeah.
it's easy, like 1G, 2G, 3G. Right, so it's NR. It's called that standard, the actual wireless standard. There's ITU, International Telecommunications Union, which is in Europe. They govern all the communications in the whole world. So and 5G came out, and it brought a lot of new stuff to the table. And that's where the latency and data speeds are coming into play. There's a video of actually somebody performing remote surgery on the banana, right? Like, it just tells you, like, now we're at the gate where we can actually start thinking about that. Telemedicine, they call it. And that's a short bite for you about 1G, 2G, 3G, 4G, 5G.
Like, who's controlling spectrum, and like, why spectrum have so much value in it? Why company try to go on auction to buy the spectrum, and what the spectrum actually worth?
That's a good question. Nobody knows that answer. So because it's an auction, right? So the price of the spectrum was determined by the auction, right? So it's how much you're willing to pay for the spectrum you want, right? Some companies are desperate to get some pieces of that spectrum. Usually when we talk about wireless communications, we talk about layer cake. Low band spectrum, lower layer of your cake, and it provides coverage because the low band spectrum and the low band signal penetrates obstacles, walls, vegetation, and so on and so forth. It provides coverage. Higher spectrum, mid band, it has both worlds, a little bit of capacity gain versus the low band spectrum, and also it provides good characteristics in terms of propagation, like the low band spectrum. Unlike the higher band, which is usually millimeter waves, it provides great capacity, but it doesn't propagate that well as the low band. I mean, it can't penetrate the window. If you have the window between your phone and the base station, you'll be losing a lot of data. The other question would be who is the seller, right?
Yeah, who's the seller? Yeah,
right. So spectrum is it's like air, right? Like there's nothing. But the rights or license to send something in the air using these specific frequencies is government controls it. So there's FCC, which is Federal Communication Commission. That's the number one governing body for all the spectrum, and they also manage the spectrum auctions. FCC provides opportunity for the operators or whoever wants to buy that spectrum to license. So they buy license, and so they say, hey, this is your license for you bought 20 megahertz of this spectrum, for example, or like 30 megahertz or whatever you bought, and you can't transmit. Nobody else can transmit on it. And nobody can interfere in this frequency. It's yours to use.
Is that going to be controlled, or like what if I want to transmit same frequency like somebody else doing?
Oh, you'll be penalized basically.
Really?
But, oh yeah.
It's a big penalty for that?
Of course, yeah. You can't transmit anything on you. We have unlicensed spectrum like Wi-Fi, Bluetooth. So we have these devices that are transmitting when they don't pay anything because it's unlicensed spectrum.
Okay.
So, but licensed spectrum, I'm just giving you a few examples, right, that you were asking. It's like gold, you're right. Some of the operators, they don't have enough bandwidth in some of these big bands like I talk about, like layer cake, lower, mid band, or millimeter wave, high band. So capacity here, data, huge amount of data, but less coverage. Coverage, less capacity. Right?
Wow.
So if you're an operator, you wanna be represented in all bands, so you can provide coverage, and you can provide capacity and high amounts of data. And sometimes FCC does the auction, and they say, hey, we have 40 megahertz of spectrum in low band, and we're setting it up for auction. So, for example, the TV stations in some of these frequencies, and they asked them, hey, since you guys are doing digital TV now and you're using some different spectrum, we're asking you to vacate the frequencies that you had and transmit it, and we'll put it up for the auction, right? So same thing with current auction, for example, that is going on right now in FCC. It's slated to get, it's already at $70 billion, and it's going. So
Wow,
no, it's not
$70 billion.
completed. So it means it's going to complete at 70 or more. The numbers that you're talking about when they auction the spectrum. Huge.
That's a lot of money.
Huge amount of money.
Huge.
Yeah. And, you know, it's not like a single operator will buy everything. It's everybody will be bidding. They're getting different pieces of that spectrum high. Yeah.
Interesting.
Yes. Yeah. And that spectrum auction right now is for 3.5 gigahertz, so which is a mid-band. It has both characteristics, good coverage and also good capacity.
It was a very interesting conversation. Thank you so much, Vadim, for coming today. It was very interesting.
Thanks, Oleg. Thanks for having me.
Thank you.